Right, grade 12s, we move on to the next page of your calculus notes, which is entitled The Derivative. I'm just going to go through this page and the next page or two, just to make sure we all up to speed with where we are in the chapter. So it says the derivative, it would clearly be useful to find a method which we can use to find the gradient at any point on a given curve without having to do a complete calculation every time. The derived function, or the derivative, makes this possible. The derivative of fx is calculated as, so the derivative is equal to the limit as h approaches 0 of f of x plus h, okay, we're adding a little bit extra there, a small change, minus f of x over that small change h. So this is a very important formula, okay, and you're going to always be asked to use this formula in exams and tests, okay. This derived function gives the gradient of f at an arbitrary point x. So to calculate or to find the gradient at x of 1, for example, we substitute in the derived function to find the first derivative when x is 1, right? Given that fx is equal to x squared, which is a basic parabola, determine the derivative. So we don't want the gradient at a point just yet. We want the first derivative, or the formula that describes what the gradient would be at a point. Okay, we would then use that formula to then find a gradient when we are given a certain point. Okay, so there's the first derivative notation, is equal to the limit as h approaches naught of, remember, there's the standard formula. Okay, so now we apply that formula to this parabola we've got. Instead of x squared, we've got x plus h all squared. That's the small change. Minus x squared, which is simply our function we're dealing with, divided by h. Times that out, FOIL it out, x squared plus 2xh plus h squared, and then minus that x squared. The x squareds will cancel. I can take out an HCF of h, right, from here. Just to add that in, you could say, take out an h, I've got x or 2x plus h, all over h. I could then cancel the h's there, and I'm left with the limit as h approaches 0 of 2x plus h. Now that h approaches naught, so the limit here is 2x. Okay, so now it then says, now to determine the gradient at x of 1, calculate the first derivative when x is 1. In other words, just sub 1 into our 2x there, into the x over here. So 2 times 1 is simply 2. So for the gradient at x is 5, then it also says, work out what f dash 5 is, the first derivative when x is 5. So 2 times 5 is 10. Okay, so instead of doing what we were doing on the previous page, by working out straight away x is 2, what is the gradient at 2? What is the gradient at negative 2? What is the gradient at negative 1? What is, you get what I'm saying? Instead of doing it straight away, we first of all work out that first derivative from first principles. That's the name for this lengthy process. We get our answer there, and now we sub in x is 1, x is 5, and so on. Okay, so this is very important, first principles, and you were given several to work through. Okay, f is equal to x, straight line, that's a hyperbola, a constant value, parabola, a cubic graph, which we'll get to. Okay, so for all these, we have to first find the first derivative, just like we did in this example up here, and then possibly, yeah, in number 2, hence calculate the gradients of the curves at negative 2. So then we would have sub negative 2 into the first derivative of all those. Okay, so I've got the answers here in my scribble. So for number 1.1, I'm just going to go through it quickly. 1.1, you've got fx is equal to x. In other words, y is equal to x, which is a straight line. So to work out the first derivative, remember, we first write out the basic formula, right? Then there is now, here's our fx, which is simply x. So x plus h minus x. Okay, so the x's will cancel and you'll have h over h, which is 1. So the first derivative of this function is 1. In 1.1.2, you've got negative 2x plus 1, a straight line. So look carefully. There's our formula here in action. Negative 2 of what? X plus h. We've added a little something, a little small change. Minus, what's our function name? Negative 2x plus h. We are minusing the whole of fx. So that's why we've used brackets. We then times that in, we times the negative in, right? We clean it up. Our 2x, negative 2x and our 2x can cancel. And in the end, I'm going to have negative 2h over h. I can cancel my h's, and my answer is negative 2. Okay? Do you notice, though, that for straight lines, there's no x left in our answer. So when we sub in values, we have no x to sub values into. So bear that in mind for when we get further down the line just now. Right. For 1.2, the question said, where can you see it? The question said 1 over x. And 1.2.2, negative 3 over x. So both of those are hyperbolas. So when we go to the answer here, for 1.2.1, there is our fx, but instead of just an x, you've got an x plus h. 1 over x now becomes 1 over x plus h, minus 1 over x, all over h. You need to now find a LCD. The LCD in the numerator will be x brackets x plus h, right? There it is there, x brackets x plus h. And instead of dividing by h, I've chosen to times by 1 over h. Does that make sense? Now, you clean up your numerator, x minus the x will be no more x's, and you've got negative h at the numerator. There it is. I could also times in my bracket there to give me x squared plus hx. Times 1 over h will allow me to cancel that h with that h. So I'll have negative 1 over x squared plus hx. Now, if my h heads to naught, that heads to naught, so that little term there is naught. So I'll have negative 1 over x squared as my answer. Or I could write it negative 1, x to the negative 2. Remember, if I had to bring that x squared to the top, it'll go to x to the power negative 2. Okay, I'm not going to do 1.2.2. It's pretty much the same as 1.2.1. Okay, for 1.3, you had the question fx equals 1, right? You will note that in my solution here and the one you may have looked at already, the first derivative of a constant will always be 0, right? For 1.4, there's the question here, and 1.4.2, those are both parabolas, 5x squared and negative 3x squared plus x. You'll see my answers here. 1.4.1, there it is, the first derivative as x approaches naught, 5x squared, but instead of an x, I'm going to have x plus h all squared minus 5x squared all over h. Deal with that, FOIL it out, times the 5 in, I get that, over h. Cancel the 5x squared are gone. I take out an HCF, I've taken out 5h. I could only have taken out of h if I wanted to. I could then cancel the h's, and I'm left with that. Times the 5 back in, I get 10x plus 5h, and the 5h would disappear if my h approaches naught. So I'll be left with 10x. 1.4.2, remember it was a bit of a more hectic parabola, negative 3x squared plus x. So look carefully here. Whenever I see an x, I replace it with an x plus h, right? So negative 3x plus h squared plus x plus h, right? Minus f of x, so minus negative 3x squared plus h, all over h. A lot of foiling and simplifying involved there. I'm going to get that as my numerator. I'm going to cancel my negative 3x squared with my 3x squared. I'm going to cancel my x with my negative x. There's my cleaned up numerator. If I take out an h as an HCF and cancel with the denominator, I'm left with that. Then as that was my h approaches naught, so the middle term will disappear, and my answer will be negative 6x plus 1 over there. Okay. 1.5 is where you are heading in matric now, is where you've got cubes. So our graph is x cubed, or in 1.5.2, negative 2x cubed. So where's my 1.5.1? There we go. So x plus h, all cubed, minus x cubed. Once again, times that out, cancel with the h at the bottom, and my answer is 3x squared. 1.5.2, negative 2x plus h cubed, minus negative 2x cubed. You see, it's always got an h in this first term over there. All over h. FOIL it out, times it out, cancel with the h, I'm left with that. And as this should be as an h heads to naught, that term will be the only one that is left, because that term and that term will both become zeros. There's my answer. Okay, so the exercise ended off with you being asked, hence, calculate the gradients of the curves at the above functions at x equals negative 2. So for all of the ones, did they ask for all of them? Yeah, but I've just focused here. For 1.4.1, 4.2, 1.5.1, 1.5.2, all you now need to do is sub in negative 2 into your first derivative answers that you worked out earlier. So 1.4.1, 5 of now negative 2 will tell you your gradient at negative 2 is negative 10. 1.4.2, you sub in negative 2 there. Your gradient at negative 2 is therefore 13. And so on for 1.5.1 and 1.5.2. Okay, this is all what we like to call, remember, first principles. Vitally important. You will get asked this for 5-6 marks in every matric exam. So get on your toes, or be on your toes for it. Okay. Right, I think these are the notes that you were given today. Alternative notations for first derivatives. So I'm going to make a separate video for this, and yeah, go through these videos carefully. I do hope that they assist you.